Hello and welcome to Sleepy Science Story. This is your time to slow down, to let the world soften at the edges, and to drift somewhere quieter for a while. Tonight, we're going to wander gently through the warm breath of the earth and the cold hush of the deep sea. A cozy trail of calming facts about volcanoes and oceans, fire and water, and all the quiet mysteries in between. I do hope this video isn't so interesting that it keeps you awake, but if it does, at least you'll be falling asleep with a head full of molten mountains, glowing fish, and the slow rhythms of the sea. Before we begin, I'd love it if you could give this video a gentle like, and maybe tap subscribe if you'd like to hear more sleepy science stories in the future. Let me know in the comments where in the world you're listening from tonight and what time it is where you are. It's always lovely to imagine this slow science drifting across time zones like soft waves. Let's begin in the most familiar part of the sea and slowly let ourselves drift downward. Imagine floating on the surface, where the light dances like 1,000 tiny mirrors and the waves catch the sky's reflection just right. The sun is still warm here. You can feel it on your face as you bob along in the slow rhythm of the ocean's breathing. But just beneath your feet, something changes. The light filters down in long threads, thinning gently as you descend. Blue becomes darker blue, then a deep indigo, and then something closer to ink. There is no edge where the shallow ends and the deep begins, no sudden moment. Only a quiet transition, like the fading of a candle at the end of a long night. The deep sea begins not with a shout, but with a hush. It's not defined by a sharp line, but by the absence of light. Most sunlight fades away by about 200 meters below the surface. That might not sound like much, but it's deeper than most scuba divers ever go. By then, red and yellow disappear first. Even the color blue, which travels farthest in water, begins to fade. Eventually, there is no color left at all, only the suggestion of light, then darkness. This is where the ocean becomes something else entirely. Not hostile, not dangerous, just different, slower, older, more deliberate, and yet it is not empty. The creatures that live here have no use for sunlight. They've adapted in ways that seem more like science fiction than nature. Some glow with soft internal lights, like fireflies suspended in water. Others have large, delicate eyes tuned to pick up the faintest bioluminescent flicker. There are fish with transparent heads and shrimp that pulse with neon stripes. But here, in the upper boundary of the deep sea, most animals rely less on vision and more on touch, pressure, and patience. The world is quiet and cold, and everything moves with a kind of unhurried grace. Pressure increases with depth, but it does so gently, steadily, as if reminding you not to rush. For every 10 meters you descend, another atmosphere of pressure is added. That means at just 1,000 meters below the surface, the water is pressing in with the force of 100 Earth atmospheres. It's like being hugged by the planet itself, not crushing, just constant. And somehow, life thrives within that embrace, not in spite of the darkness and pressure, but perhaps because of it. There is a calmness here that's hard to describe. No waves, no surface chatter, just the slow swirl of currents moving heat and salt around the globe. Every now and then, a piece of the surface world drifts down. A flake of algae, a fish scale, even snow, not the cold kind we know on land, but something called marine snow. Tiny particles of organic matter falling like soft, endless confetti. It never stops, it never hurries, it simply descends, a silent snowfall that feeds the deep. And this is only the beginning. The deep sea goes far deeper than this first breathless descent, but here, just beyond the reach of sunlight, the ocean has already become something dreamlike, something quiet and immense, waiting patiently just below. Beneath the gentle undulations of the sea, where the weight of water has quieted all sound, there are volcanoes that no one sees. They rise from the ocean floor slowly and in silence, not with fanfare or fire, but with a deep persistence. These submarine volcanoes make up the majority of volcanic activity on Earth, yet they remain largely invisible. There is no smoke, no ash cloud, no orange glow on the horizon. Instead, they work in the darkness, shaping the planet with each unseen eruption. Some form long ridges that stretch for thousands of kilometers. Others build entire underwater mountains, tall enough to rival those on land, their peaks never quite breaking the surface. When people think of volcanoes, they often imagine the towering cones of places like Mount Fuji or Vesuvius. But the truth is, most volcanic activity takes place where light cannot reach. Deep beneath the waves, tectonic plates pull apart ever so slowly, and molten rock rises to fill the gap. It spills out into the cold water, where it cools instantly and hardens, adding a new layer to the seafloor. This slow, steady process forms what is called mid-ocean ridges, which are like the seams of the Earth's crust. They are not narrow or precise, but wide and winding, like an old riverbed made of fire and stone. Sometimes these submarine volcanoes erupt with such intensity that they create islands. Other times, the eruption is gentle, more like an exhale than an explosion. The lava meets water and cools into strange bulbous shapes that stack upon one another. These are called pillow lavas, and they form in clusters, like smooth stones piled carefully by a thoughtful hand. The heat does not always escape upward. Sometimes it remains trapped, creating pockets of warmth beneath the ocean floor. These heated chambers, rich with minerals, can become the birthplaces of hydrothermal vents. But that is another story for another gentle descent. There are places in the world where this volcanic activity is particularly concentrated. Around the edges of the Pacific Ocean, the seafloor is restless. This region, often called the Ring of Fire, circles the ocean with thousands of volcanoes, many of which are beneath the surface. They hum with quiet energy, their lava flows hidden from view, their shaping of the earth unnoticed except by the ocean itself. Even when they are not erupting, they pulse with potential, building pressure slowly, like a drumbeat only the planet can hear. To be near one of these undersea volcanoes would not be frightening. It would be surprisingly calm. The eruption might begin with a release of gas, a slow bloom of warm water, or a faint tremor in the surrounding rock. Then the lava would rise, moving slowly, more like syrup than fire, meeting the cold and transforming at once. And then the silence would return, the sea would settle, the volcano would rest again. These mountains beneath the waves are part of the Earth's breathing, a rhythm that continues whether we are watching or not. They do not seek attention. They simply build, erupt, cool, and wait. If you could hover gently above a fresh undersea lava flow, the scene would be almost surreal. Instead of jagged rocks and roaring flames, you would see shapes that look soft and rounded like cushions stacked on top of one another. This is pillow lava, one of the ocean's quietest and most beautiful sculptures. It forms when molten rock escapes from a crack in the seafloor and meets the cold water. Instead of splashing violently, the lava balloons outward. Its outer layer hardens almost instantly, forming a thin shell, while the still molten center pushes forward, swelling the shell like a bubble until it bursts through and makes another pillow. Over time, these bulbous shapes pile up into sprawling fields that stretch across the passer, seafloor like a frozen quilt. There is something strangely peaceful about the way this process unfolds. On land, lava can flow quickly, burning and reshaping everything in its path. Underwater, it moves slowly and deliberately. Each pillow forms in near silence, only the hiss of cooling rock and the faint tremor of new crust being born. The water takes the violence out of the eruption, turning it into an act of quiet creation. The shapes left behind are smooth and round, like stones polished by centuries of waves, even though they were made only moments before. Sometimes these pillow lavas create small caves and tunnels where the still molten lava once flowed, now empty and waiting for deep-sea creatures to explore. The colors in a pillow lava field are muted but rich. Fresh pillows are dark, almost black, glinting faintly under a submersible's lights like wet obsidian. Older pillows take on rusty tones as iron in the rock reacts with seawater, hinting at the slow passage of time. Between the pillows, soft sediments settle, forming a thin dusting of pale material that drifts like snow between stones. In these quiet crevices, small animals often make their homes. Tube worms, tiny crabs, and delicate starfish cling to the surfaces, taking advantage of the warmth and minerals still seeping from the cooling rock. Pillow lava is not rare. In fact, most of the ocean floor is covered with it. Every inch of new seafloor created at mid-ocean ridges begins as pillow lava, forming the foundation of the deep sea. It is easy to forget that the ocean floor is constantly renewing itself, but each pillow is a sign of this slow process. The earth is making new skin, layer by layer, pillow by pillow, in a cycle that has been going on for hundreds of millions of years. Even the continents we stand on were once part of this hidden process, long before they rose above the water. To imagine the scale of it is to feel small in the best way. Vast, dark fields of rounded rock stretching for thousands of kilometers, unseen and unhurried, shaping the world beneath the waves. Each pillow is a moment of contact between fire and water, frozen into form. Together, they are the quiet handwriting of the planet, spelling out its story one rounded shape at a time. Far beneath the reach of sunlight, where darkness wraps around everything like velvet, the ocean comes alive in ways that feel more like dreams than reality. It is a world without sky, without weather, and without color as we know it. But here, in the stillness, light returns, not from above, but from within. Bioluminescence is the name scientists give to this quiet magic. It is the gentle glow made by living things, tiny sparks in the blackness like stars drifting through water. Imagine floating in a submersible, your lights dimmed, your surroundings an endless shadow. Then, suddenly, a flicker. A soft pulse of green or blue glows just beyond the glass. Another flicker appears, and then another, like fireflies dancing in slow motion. These lights belong to animals that have adapted to a world where sunlight never comes. They make their own glow using chemical reactions inside their bodies. Some flash to distract predators, others shimmer to attract mates. Many pulse softly, rhythmically, as if breathing light in the dark. There are jellyfish that glow in delicate rings, their transparent bodies almost invisible except for the halo they carry. Tiny fish with spots along their sides light up like landing strips. Some squid release clouds of glowing ink, creating confusion in a place where seeing is already a challenge. Even some sharks carry glowing bellies, not to light the way, but to disappear. When viewed from below, the dim light on their underside matches the faint glow from far above, hiding their silhouette from anything watching beneath. The colors of this underwater glow are mostly blues and greens. Those are the wavelengths of light that travel farthest through water, so creatures have evolved to see and emit those hues. The effect is soft and eerie, like lanterns carried through a fog that never lifts. It is not the harsh brightness of a flashlight or the flicker of a flame, but something slower and smoother, a whisper of light. What's most extraordinary is how common this glow is in the deep sea. Scientists believe that the majority of deep-sea animals produce some form of bioluminescence. It's not rare, it's normal here. It's a quiet conversation carried in light instead of sound. It is how life communicates in the absence of eyes, color, and shadow. The glow doesn't always mean movement. Sometimes it pulses in patterns that repeat and fade, like lullabies written in flickers. These patterns are not random. They are meaningful, even if we don't yet understand the full language. One species of comb jelly glides through the water with waves of rainbow shimmer rolling down its body. Another carries a light on a tiny stalk above its head, like a fisherman's lure patiently waiting for something curious to come close. To look into this dark, glowing world is to be reminded that nature often reserves its most delicate beauty for places where no one is watching. The deep sea glows not for applause, but simply because it can. And in that glowing silence, the ocean dreams. If you were to drain the ocean completely, not all at once but slowly and gently, like tipping a giant bowl, something astonishing would begin to emerge from the water. Off the coast of Hawaii, a mountain would rise higher and higher, stretching far above where the sea once kissed its sides. At first, you might recognize it, a familiar island perhaps. But as the water slips away, more and more of it appears. What you'd be looking at isn't just a mountain, it is Mauna Kea, and from base to summit, it is the tallest mountain on Earth. Measured from its base on the ocean floor to its snow-dusted peak, Mauna Kea rises over 33,000 feet. That makes it taller than Mount Everest, even if most of its height lies hidden beneath the sea. This mountain has no need to boast. It has no flags at the top, no climbers gasping in thin air. It simply exists, ancient and patient, with its roots deep in the crust and its crown brushing the edge of the sky. Mauna Kea is a volcano, though it has been silent for thousands of years. Its shape is broad and gentle, a shield volcano formed by countless flows of lava that spread like syrup and cooled into soft slopes. Underwater, the lower parts of the mountain are darker, rougher, shaped by pressure and time. Above water, the landscape becomes drier and smoother, with cinder cones rising like smaller echoes of the great summit. What's remarkable is how this massive structure formed. The Hawaiian Islands are the result of a hot spot, a fixed plume of heat deep in the Earth's mantle. As the Pacific tectonic plate slowly drifts over it, magma rises through the crust, building islands one after another in a quiet procession. Mauna Kea was once the most active of these, though now its younger sibling Kilauea carries that torch. At night, from Mauna Kea's summit, the sky stretches wide and clear. Astronomers have built observatories here, high above the clouds and far from the glare of city lights. But it's easy to forget that this lofty perch rests on a mountain mostly submerged. More than half of Mauna Kea sleeps below the sea, hidden from view but no less immense. To picture this mountain is to picture the hidden strength of the planet. It grew slowly, eruption by eruption, over millions of years, and though its summit may be silent now, it stands as a reminder of the Earth's quiet persistence. It does not roar, it does not hurry, it simply is. So, when we think of the tallest peaks on Earth, perhaps it's worth remembering the ones we cannot fully see, the ones that stretch down instead of up, the ones that rise not just above sea level, but from the deep heart of the planet. Mountains like Mauna Kea, holding up the stars while keeping their foundations anchored in the sea. Beneath the open sea, far from shore and far from sight, There is a place where the earth is quietly pulling itself apart. Not in a violent way, not with a great tear or shudder, but in a slow, steady stretch that never stops. This place is called a mid-ocean ridge, and it is where the seafloor is always growing. Imagine two enormous plates of the Earth's crust drifting away from one another. Between them, molten rock rises from deep below and cools into new seafloor, adding a little more to the edges day by day. It happens so slowly that you could sit there for hours and see no change, but over thousands of years it reshapes oceans. The process is called seafloor spreading, and it's one of the ways the Earth renews itself. You could think of it like bread dough rising in the oven, slowly expanding at the seams. Or like a quiet river of rock, always flowing but never rushing. As the plates move apart, magma fills the space between them, cools, and hardens into basalt. Over time, layer upon layer builds a new stretch of ocean floor. It doesn't happen in a straight line. The ridge itself twists and turns like a scar across the seafloor, sometimes smooth and gentle, other times broken and jagged, shaped by pressure and time. The most famous of these ridges is the Mid-Atlantic Ridge, which runs like a hidden backbone down the center of the Atlantic Ocean. It stretches from the icy waters near Greenland all the way to the southern tip of Africa. It is not a wall, but more of a long underwater mountain range. Some parts of it even rise high enough to form islands. Iceland, for example, is part of this ridge, peeking up above the waves where the plates are pulling apart. Standing on the ridge would be impossible without the help of a submersible, but if you could somehow drift there, you'd see steep cliffs and deep valleys, places where rock has cracked open and cooled into wild formations. The water is cold and still, but not lifeless. Around these rift zones, hydrothermal vents often form, releasing plumes of heated water and minerals. Life gathers near them, feeding off the chemicals that seep from the Earth's crust. It is a place of both birth and mystery, where geology and biology come together quietly in the dark. What's most calming about this whole process is its rhythm. It doesn't stop, it doesn't race. It just continues, slow and sure, a few centimeters each year, about as fast as your fingernails grow. And yet, over the course of millions of years, this gentle motion has created entire oceans, separated continents, and shaped the face of the planet. So the next time you stand at the edge of the sea, know that far beneath your feet the Earth is still creating, still moving, still exhaling new seafloor into the vast unseen world below. It does not hurry. It simply becomes. In the deepest places of the ocean, where sunlight has never once touched the water, a strange kind of warmth rises from the seafloor. It is not the warmth of sunshine or of tropical air. It is older, quieter, and comes not from the sky but from the center of the earth. These are hydrothermal vents, and they appear near undersea volcanoes, where the crust of the earth is thin and the ocean floor breathes in heat. If you were to descend into one of these regions, through the dark and pressure-filled silence, you would eventually find columns of water rising like smoke from the rocks. But it is not smoke. It is superheated water, rich with minerals and warmer than anything else around it. Some of these vents release water so hot it could boil at the surface, though down here, where the pressure is immense, it remains liquid. The water gushes upward from cracks in the ocean floor, forming tall chimneys built from the minerals it carries. Over time, these chimneys grow higher, reaching toward the proof, a surface they'll never touch, like stone trees rising in a midnight forest. There is a stillness to this landscape, even as the vents pulse and steam. The chimneys are blackened and twisted, shaped by heat and water in equal measure. Around them, the ocean is filled with fine particles, drifting like ash in slow motion. The scene is not bright, but not completely dark either. Some of the minerals glow faintly. Some creatures bring their own light. The vents do not roar, they whisper. And somehow, in this place where there is no sunlight, life flourishes. Entire communities gather around these vents, drawn by the warmth and the strange chemical stew they release. Here, organisms do not rely on photosynthesis. They rely on something called chemosynthesis, a process where bacteria take the minerals in the vent water and turn them into energy. These bacteria form the foundation of an entire food web, one that exists without ever seeing the Sunday giant tube worms, with soft white bodies and bright red plumes, anchor themselves to the rock. They have no mouths, no stomachs, and yet they thrive. Inside them have lived the bacteria that feed on the vent chemicals, and the worms, in turn, feed on the bacteria. It is a partnership so strange and delicate that it almost feels imagined. Around the worms, crabs scuttle, shrimp hover, and fish drift in slow circles, all drawn to this oasis in the dark. These vent fields are not permanent. Over years or decades, they can shift, cool, or collapse. New ones will form nearby, and life will follow. It is a cycle of quiet transformation, happening in a place where no light guides the way. But even here, in the darkest parts of the world, the earth continues to create. And life, in its quiet wisdom, finds a way to welcome the warmth rising from stone. Far below the surface of the ocean, where the weight of the water presses from every direction and the darkness feels almost alive, there is a kind of quiet that few places on earth can match. It is not the silence of an empty room or the hush of snowfall, but something deeper, a stillness so complete that even the slowest sound can travel for miles. Down here, in the deep sea, noise behaves differently. It moves with patience, it lingers, and sometimes it carries the whispers of the earth itself. In these depths, thousands of meters below the waves, there are no crashing surf sounds or chirping birds. There is only the low hum of water shifting past rock, the occasional creak of a tectonic plate adjusting ever so slightly, and the distant rumble of things too far away to see. Scientists have lowered sensitive instruments into the deep and discovered that the earth has a voice here, not loud, but persistent, a low, rolling frequency that seems to stretch out forever. They call it seismic noise, a natural vibration made by movements in the crust. In the absence of other sounds, it becomes the background music of the deep. You might imagine that this silence would be unsettling, but it is more comforting than eerie, like being wrapped in soft blankets made of water and time. Every now and then, something stirs. A whale call, traveling from dozens of kilometers away, will echo through the depths like a slow song. A submarine volcano might shift, releasing a bubble of sound that rises and fades. Even small earthquakes, happening hundreds of miles away, can send ripples through the deep that murmur like distant thunder. It is in this stillness that deep-sea creatures live their lives. Many of them do not make noise, but they are tuned to listen. Some fish can detect pressure changes and subtle vibrations through their bodies. Others use their lateral lines, special sensory organs that let them feel motion in the water. In a world without light, touch and sound become essential. A small shift in the current might be food approaching, or danger. Every ripple matters. The pressure down here is immense. Every square inch is squeezed by tons of water, and yet the silence remains unbroken. Unlike the surface, there are no crashing storms to disrupt the peace. No wind, no waves, just the slow and constant weight of the ocean pressing inward. And beneath it all, the earth turns. Plates move, magma shifts. But the changes are slow and quiet, like the creaking of an old house settling into the night. Listening to the deep sea is like listening to a planet sleeping. You do not hear sentences or stories. You hear rhythms, the slow exhale of the crust, the faint sigh of tectonic plates finding a new position. It is a lullaby made not of melody, but of motion, and in this gentle underwater silence, the earth dreams. There are volcanoes in the ocean that live and die without ever being seen. They rise from the seafloor, build themselves slowly from layers of cooled lava, and spend their entire existence beneath the waves. Some begin as small cracks in the Earth's crust, letting out gentle streams of molten rock. Over time they grow taller, sometimes forming steep-sided cones or wide-rounded mounds. But they never reach the surface. They remain in the dark, their peaks still hundreds of meters below the sky. These are submarine volcanoes that never break through the ocean's surface. They are quieter than their land-based cousins, but no less important. In fact, they make up most of the volcanic structures on Earth. For every fiery eruption we see on land, there are many more that happen out of sight. Down here, lava flows are slower, cooler, and shaped by the pressure of the deep. When the molten rock meets cold seawater, it solidifies almost instantly, forming strange rounded shapes and hard crusts. The eruption becomes a process of layering, not exploding. Over thousands of years, these underwater volcanoes can become enormous. Some grow tall enough to be classified as seamounts, which are underwater mountains that rise at least 1,000 meters from the seafloor. Others remain smaller, their growth halted by a lack of fresh magma or a change in the movement of the tectonic plates. Some collapse inward, leaving behind calderas, which are large, sunken craters shaped like sleeping eyes. A few develop crater-like tops with gentle slopes, while others form sharper ridges and valleys carved by underwater currents and shifting rock. Despite their invisibility, these volcanoes play a vital role in shaping the ocean floor. They create new habitats for marine life, change the path of underwater currents, and contribute to the chemical balance of the sea. Their surfaces provide hard ground, where corals, sponges, and deep-sea creatures can settle. In a world dominated by soft sediment and shifting sand, a solid rock is a welcome anchor. Many of these volcanoes never erupt in a dramatic way. Instead, they quietly release heat and minerals over time. This slow seepage can attract life in strange and beautiful forms. Microbes cling to the warm stone, feeding on chemicals that drift out of the cracks. These simple organisms form the base of entire communities, creating small pockets of life in places that would otherwise be barren. Some of the largest known underwater volcanoes were discovered only recently. Until the right technology came along, we had no idea they were even there. Sonar mapping, satellite data, and submersibles have revealed mountain ranges and craters as complex as anything found on land, and yet many remain unnamed, untouched, and unexplored. To think that such massive structures can live in complete darkness, unnoticed for millions of years, is a gentle reminder that most of Earth's story still lies beneath the surface. These volcanoes may never touch the sky, but they shape the planet just the same, quietly, patiently, in the stillness of the deep. Some volcanoes do more than build mountains or spill lava across the ocean floor. Some of them sing. Not in the way birds do, or whales, but in slow, deep sounds that echo through the water like a voice, too ancient to hurry. These are submarine volcanoes, and when they erupt, they sometimes release not only heat and rock, but also vibrations that travel far through the sea. Scientists have recorded these sounds using underwater microphones called hydrophones. What they've found is that the Earth speaks in tones so low and slow that we cannot hear them without help. The volcano's song is not meant for human ears. It is more like a hum that ripples across the ocean, as if the planet is sighing from deep within. These sounds are called low-frequency harmonic tremors. They begin as magma rises and shifts inside the volcano, squeezing through narrow pathways in the rock. The movement creates pressure, and the pressure becomes sound. Sometimes the eruption itself adds to the chorus, with lava bubbling and gases escaping into cold seawater, each motion sending out a new pulse. The result is a kind of underwater music that can continue for hours, sometimes even days. It is not chaotic, it is rhythmic, almost like breathing. The deep sea carries these vibrations across great distances. Water is a good conductor of sound, and in the quiet of the deep ocean, there are few obstacles to slow the waves. Some of the songs from underwater eruptions have traveled hundreds of kilometers, caught by listening instruments placed far from the source. To the scientists studying them, each sound tells a story. A certain pitch might suggest magma rising. A change in rhythm might signal a collapse or a cooling. It is like listening to the heartbeat of a volcano, steady and real. There is something peaceful about the idea that the Earth has a voice, even if we can only hear it through machines. It sings, not for attention, but because that is what it does. Each sound, each tremor, is a part of its long, slow conversation with the ocean above. These submarine songs are never loud, they do not startle. They roll forward like waves of sound, smooth and deep, passing unnoticed by the creatures swimming nearby. Some of these underwater sounds have been mistaken for the calls of unknown animals. Others are so regular that they seem almost artificial. But always, when traced back, they come from the slow and steady breath of the earth. A volcano in the South Pacific once emitted a sound so constant and pure that it was compared to the tone of a bell ringing beneath the sea. No eruption followed. The volcano simply hummed. Listening to these sounds reminds us how much of the planet remains quiet on the surface while active below. Not all volcanoes explode. Some whisper, some breathe, and some sing lullabies made of stone and fire, carried softly through the water, never needing an audience to be beautiful. After a deep-sea volcano erupts, the world it leaves behind is not peaceful right away. The lava cools, the vents quiet, but the seafloor is left black and bare. It looks lifeless at first, like a charred plain stretching into the dark, but something remarkable happens in the days and months that follow. Life returns. Slowly, quietly, and with a kind of softness that feels almost like forgiveness, the creatures of the deep begin to arrive, not in a rush, but in a patient drift. First come the microbes, invisible to the eye, but full of purpose. They settle on the cooling rocks, feeding on the chemicals that still seep from the cracks. These simple organisms are the first step in rebuilding. They form thin films on the new surfaces, clinging to the curves of pillow lava and the edges of broken stone. Though tiny, they change everything. They create a kind of foundation, something that other life can build upon. Over time, slightly larger creatures arrive. Small worms burrow into the soft sediment that begins to gather. Shrimp and crabs explore the cracks, picking at the microbial mats, searching for warmth and food. Tube worms appear next. They do not come from the surface, but from nearby. Their larvae drift through the water, carried by deep currents, waiting for just the right moment to settle. When they find a vent still releasing warmth, they anchor themselves to the rock and begin to grow. Their red plumes unfurl like petals, reaching into the water to collect nutrients. Inside their long bodies, bacteria continue the work of turning chemicals into energy. These worms have no mouths and no need for sunlight. They exist in quiet partnership with the microbes that nourish them. In time, more animals arrive: mussels, anemones, snails, each one drawn to the still warm seafloor, each one adding to the growing community. It becomes a garden, not of green but of white and red and soft movement. The creatures do not hurry. They simply take their place. Even fish return, gliding through the shadows, pausing near the vents like travelers resting beside a fire. What is most comforting is how certain this process is. Even in the aftermath of fire, even in the darkest parts of the world, life returns. It does not question. It does not wait for perfect conditions. It finds warmth and builds. The deep sea does not see the eruption as an ending, but as a beginning. A new surface to grow on, a new patch of earth to make into home. So beneath the waves, on seafloors scorched by invisible volcanoes, nature carries on. The ocean wraps its arms around the new rock. Creatures gather, not in noise but in stillness. They rebuild slowly, like a whispered story told one word at a time. And in that story, life blooms where fire once was, soft and glowing, cradled in the quiet of the sea. Far beneath the waves of volcanic islands like Iceland or Hawaii, beneath the mountains and valleys that shape the ocean floor, there are chambers of molten rock that pulse with slow, steady warmth. These magma chambers are the quiet heart of every volcano, sitting deep in the crust like pools of liquid fire. They do not shout or shake most of the time. They wait. And above them, sometimes directly above, the seafloor can be unexpectedly calm. You might expect such a place to be violent, jagged, or lifeless, but often the exact opposite is true. In many places above these underground reservoirs, coral gardens stretch across the rocky seabed. Their colors are pale in the dim light, but their beauty is still striking. Branches of deep-sea corals grow slowly on the cooled lava, curling like frost patterns on a window pane. Among them drift small fish, sea stars, and sponges. The water is still cool, and the pressure is great, but here, in this surprising stillness, life finds its rhythm. This balance between fire and peace is one of the ocean's quiet wonders. A volcano may have shaped the land above and below, but in the time between eruptions, the world continues without fear. Coral polyps settle on ancient basalt, tiny creatures that build skeletons from calcium and slowly create entire reefs. These reefs become homes for others, sheltering creatures that have never known the touch of sunlight. Sometimes, the heat still seeps upward. The water around these places can be just a little warmer than usual, a gentle reminder of the magma below. But it is not dangerous, at least not now. It is a slow exhale. And in that warmth, some life flourishes. Bacteria that thrive in higher temperatures form invisible threads across the stone. Shrimp and worms gather in small numbers. The occasional crab scuttles between coral branches, tracing invisible paths over stone once poured like syrup from deep within the earth. These quiet places are often overlooked. They lie between the drama of eruptions and the wonder of active vents, but their stillness is not emptiness. It is a pause in the story, a resting place between chapters. It is where destruction has ended and creation has not yet begun again, and in that pause, the ocean grows gardens. Scientists who study these zones often speak of how gentle they feel. The movement of the water is slow, the echoes of the deep are soft, instruments lower, carefully to explore, find no bursts or tremors. Only the slow drift of sediment, the gentle sway of coral, the whisper of life moving across old lava. Above the hidden heat, the seafloor dreams. It remembers fire but embraces calm, and perhaps that is the secret of these coral gardens. They do not deny the presence of the volcano beneath them. They simply grow, slowly and peacefully, in the time between the flames. Encircling the vast Pacific Ocean is a chain of volcanoes so extensive it touches the shores of many continents. This quiet loop is often called the Ring of Fire, and it holds more than 3/4 of the world's volcanoes. While some of them rise high on land, with snow-dusted peaks and steaming craters, most live beneath the sea, in the cold and darkness of the deep. They form a circle that is not drawn on any map you can hold in your hand, but one that wraps gently around the ocean like a necklace made of stone. If you could fly over the Pacific with eyes that see through water, you would trace this ring as a trail of undersea mountains and ridges. Each mark on the seafloor tells part of the story. Some volcanoes here are quiet, others are restless, their magma chambers slowly filling and shifting over time. A few erupt without warning, sending plumes of ash and gas into the sea, only to disappear again into the silence. The rest wait, their stories half told in layers of cooled lava and mineral-rich vents. The ocean hides most of these giants. Ships pass above them without notice. Storms sweep over their peaks without knowing what lies beneath. These volcanoes shape the continents slowly. They build islands, change coastlines, and carve trenches that stretch deeper than Mount Everest is tall. Some islands that exist today were not here a few thousand years ago. They rose from the seafloor, born from fire and cooled by the sea, and now support forests, birds, and even people. Despite their name, the volcanoes of the Ring of Fire do not burn, not in the way we imagine. They glow softly in the dark, their heat felt more than seen. The lava they produce flows beneath thousands of meters of water, cooling quickly and hardening into new crust. These eruptions do not shake the world with sound. They release their energy in slow pulses, felt by seismographs and known through the movements of the sea. What's remarkable is how often this ring goes unnoticed. Its presence is vast, but its touch is gentle over great stretches of time. The sea keeps its secrets well. Only through deep-sea exploration, satellites, and careful listening have we begun to understand the true size of this volcanic circle. And even now, much of it remains a mystery. There are underwater volcanoes in the Ring of Fire that have never been named, never been studied, and never been seen. The creatures that live near these volcanoes carry on quietly. They drift, they anchor, they glow. The warmth from below feeds entire ecosystems in the cold, dark water. The earth provides not with noise, but with steadiness. And the Ring of Fire, for all its power, holds that steadiness like a whispered promise. It does not close or break, it continues. It holds the edge of the ocean in a loop of stone, rising and cooling in silence, always present, even when forgotten. A hidden circle, keeping the heart of the Pacific gently wrapped. In the shadowy depths of the ocean, where the sunlight fades into memory and the pressure builds like a quiet embrace, there are chimneys that breathe. These structures do not puff smoke from fire, but instead release streams of superheated water, rich with minerals drawn from deep inside the earth. Some send out dark plumes that twist and coil like ink, while others release pale clouds that shimmer softly as they rise. Scientists call them black smokers and white smokers, named for the color of the water they release, though neither has anything to do with smoke at all. Black smokers are the more dramatic of the two. Their plumes are dark because the water they release is filled with iron and sulfur. When this water meets the icy ocean, the minerals solidify, forming fine black particles that drift upward in slow spirals. Around the vent, the minerals build up over time, creating tall, jagged towers that look like miniature skyscrapers made from soot and stone. These towers grow slowly, layer by layer, as the vent continues to breathe. Some have reached heights of over 10 stories, standing alone in the darkness like watchtowers in a sunken city. White smokers are softer in appearance. Their water carries lighter minerals such as barium, calcium, and silicon. When released, the plume is pale, sometimes almost translucent. The chimneys they build are often shorter and more delicate, with smoother sides and gentler curves. The water they release is still hot, but not as extreme as that of black smokers. Both types of vents create small oases of heat and chemistry in a place that otherwise offers only cold and stillness. Around these vents, life gathers in quiet, astonishing ways. Tube worms, with scarlet plumes, sway in the currents, their bodies tucked safely into long white casings. Shrimp with light-sensitive backs cluster near the chimneys, warmed by the flow, but careful not to drift too close. Crabs move deliberately along the rocky surfaces, picking through the mineral deposits for food. Bacteria thrive in the heat and convert chemicals into energy, forming the base of a food web that exists without sunlight. The chimneys themselves do not last forever. They are fragile, shaped by balance. If the flow changes, if the vent cools or collapses, the structure can break apart. But even when one disappears, another can form nearby. The deep ocean is always shifting, always renewing. The vents appear, grow, provide, and then return to the sea floor, becoming part of the silent foundation once more. There is something gentle in the way these smokers behave. Though they rise from volcanic heat, they do not roar or rage. They release their energy in steady breath, feeding the dark sea with minerals and warmth. In a world without light, they become lanterns of a different kind, not seen from above but felt by those who live in the deep. And as they breathe, they remind us that fire and water can work together in silence to create something quietly alive. In the world above the sea, nearly every living thing relies on the Sunday trees stretched toward it. Animals rise and sleep by its rhythm, and people feel its warmth and call it day. But in the deep ocean, where sunlight never reaches, life follows a different rule. It does not depend on photosynthesis. Instead, it is built on a quieter, older foundation. Here, organisms use the energy not from light, but from the earth itself. This process is called chemosynthesis, and it is how entire ecosystems thrive in total darkness. At the heart of this process are tiny bacteria. They live near hydrothermal vents and other cracks in the ocean floor where minerals and gases leak from the crust. These bacteria are able to take chemicals like hydrogen sulfide, which would be toxic to most surface creatures, and convert them into food. They do this not with sunlight, but with chemistry. They turn poison into energy. From that simple act, an entire web of life is built. These bacteria are everywhere near the vents. They form mats on the rocks, cling to the sides of chimneys, and even live inside the bodies of other animals. Tube worms, for example, have no mouths and no stomachs. Instead, they host these bacteria within their bodies and feed off the nutrients the bacteria create. The worms offer shelter, and the bacteria provide nourishment. It is a perfect partnership, quiet and complete. Other creatures join the community. There are mussels with bacteria tucked inside their gills, crabs that graze on the mats, and shrimp that seem to hover patiently near the heat. Each one plays a role in the balance. None of them need the Sunday, none of them miss it. They have everything they need right there in the dark. This kind of ecosystem is rare but not fragile. It exists in places where the earth is active, where heat rises and minerals seep. And when a vent stops flowing, when the warmth fades and the chemistry disappears, the community moves on. New vents open nearby, and life follows. It may take time, but the pattern always returns. Heat, chemicals, bacteria, and then the rest. A quiet cycle, deep and reliable. What is beautiful about chemosynthesis is not just its strangeness, but its simplicity. In a place that seems empty, life finds a way to begin. It does not need sunlight or seasons or rain. It only needs a gentle warmth, a few special chemicals, and the patience to grow. And grow it does, quietly and completely, in the deepest shadows of the sea. To imagine this world is to imagine an earth that breathes from within, not loudly, not quickly, but in slow, warm pulses. The life that follows is not bright or fast, but steady. It glows softly in the dark, sustained by the kindness of unseen reactions, and in the silence of the deep, it thrives without light, without noise, and without hurry. Sometimes, when a volcano rises from the ocean floor, it keeps growing. Layer by layer, eruption by eruption, it builds itself up until one day it reaches the surface. In that moment, something new is born. An island appears where there was once only open sea. The water steams, the lava cools, and the air shimmers with heat. But it is not loud, it is not sudden. It is a process that has taken thousands of years, perhaps longer. The sea simply steps aside for a moment and lets the mountain speak. These volcanic islands often begin as nothing more than a gentle dome beneath the waves. You would never know they were there if not for a slight difference in the color of the water, or maybe a faint warmth. Then one day, a plume of ash rises above the ocean surface. It curls into the sky like a slow breath. Ships passing by may notice, birds may gather, and then, little by little, stone appears where there was none before. The lava cools quickly when it meets the air. It hardens into black rock, uneven and sharp. It is not easy to walk on, but soon enough, plants find their way. Seeds carried by birds or caught in ocean currents settle in cracks. Rain fills the low spots. Over time, soil forms, then grasses, then flowers. What was once fire becomes a place for life. And all the while, the volcano may still be active, still shaping the land beneath its new skin. Some islands vanish as quickly as they appear. If the lava isn't thick enough, or the eruptions too small, the sea reclaims what was made. The waves crash and pull the rocks apart, piece by piece, until the island sinks once again beneath the water. But sometimes the volcano persists. It rises higher, pushes harder, and the island becomes permanent. It grows into a home for plants, animals, and eventually people. Hawaii began this way. So did Iceland. Each island in those chains started as a crack in the seafloor, a place where magma reached upward and met the ocean with steady patience. Now they hold forests, waterfalls, and entire cities. Yet, deep below, the volcano still sleeps. It remembers its beginnings even as the world above moves on. When you look at a volcanic island today, it is easy to forget the long story that built it. But under every step, beneath every grain of sand or blade of grass, is cooled lava, solidified time, a record of the Earth's slow work. These islands are not just land. They are the quiet result of persistence. To think that a mountain can grow from fire and rise into the sky, then soften into something green and full of life, is a kind of comfort. It means that change does not always come with noise. It can come with warmth and patience and the endless push of stone through water until the sea finally lets something new begin. If you could strip away the water from the ocean floor and stand where fish now swim, you would see something unexpected. Rising from the vast flat plains of the deep sea are mountains. Thousands of them. Most are unnamed. Many have never been seen by human eyes. They are called seamounts, and though they are underwater, they are as real and rugged as any mountain range on land. They stretch up from the seabed, formed by ancient volcanic activity, shaped by currents and time, and stand quietly in the dark like forgotten towers. These seamounts vary in shape and size. Some are steep and pointed, others wide and sloping. Many were once active volcanoes but no longer erupt. Their peaks may fall hundreds of meters below the surface, or lie just out of reach of the sunday. Some even carry flat tops, sheared off by erosion when they once stood above the sea. These flat-topped seamounts are called guyots, and they are quiet reminders that even underwater mountains can have their own histories. Beneath the surface, seamounts play an important role in the life of the ocean. They are more than just stone, they act as gathering places in the vast blue emptiness. Currents rush against their sides, bringing nutrients from the deep up toward the light. This draws plankton, which draws small fish, which then draws larger fish, and eventually sharks and whales. Seamounts become oases of life in an otherwise open and empty sea. Their slopes are often covered in corals, sponges, and other creatures that cling to the rock and sway with the water's rhythm. What makes them even more fascinating is how little we know about them. Most seamounts have never been mapped in detail. We know they are there because of sonar readings and satellite measurements, but the details remain hidden. Submersibles and remotely operated vehicles have visited only a few. What they found is surprising. Deep-sea corals growing slowly over centuries, rare species that live nowhere else, communities that thrive in complete darkness, living on the nutrients stirred up by the shape of the mountain. Many of these seamounts are older than the continents. They formed millions of years ago, when the Earth's plates were in different positions and the ocean floors were being shaped by fire. Since then, they have stood quietly, eroded by time and softened by sediment, but never erased. They are landmarks in a world without signs. And though they may never see the sun, they hold stories carved in stone. To drift above one is to float over a hidden world. The ocean might look the same from above, but far below, there are peaks and ridges, cliffs and valleys, each one silent and strong. These are the Earth's quiet sculptures, created without hurry, rising from a place no one sees, and waiting patiently in the dark for someone to remember they are there. Deep beneath the ocean's surface, far beyond the reach of sunlight, there are corals that grow not on tropical reefs, but on the ancient bones of volcanoes. These are deep-sea corals, and unlike their shallow water cousins, they do not need sunlight to survive. They live slowly, in the cold, dark waters of the deep, anchoring themselves to the hard stone left behind by underwater eruptions. The lava may have cooled long ago, but its surface offers a rare place of stability in a world often made of soft mud and shifting sand. These volcanic rocks become the quiet foundations of coral forests. Their surfaces are rough, full of ridges and grooves, the perfect places for coral larvae to attach and begin their lives. Over years, then decades, and eventually centuries, the coral grows upward and outward, forming delicate structures that stretch like branches of a tree. They are pale and slow and beautiful in a quiet way, shaped more by time than by motion. Unlike the corals in sunlit waters, deep-sea corals do not build massive reefs. Instead, they create thickets and fans, single colonies that can grow, very large but are usually spread apart. Their colors are often soft, whites and creams, with hints of pink or gold when caught in the lights of a submersible. These lights reveal a stillness that is not empty. Crabs perch on the branches, shrimp move carefully among the polyps, small fish hover in the spaces between, sheltered from the open sea. Some of the coral species found here are among the oldest living animals on Earth. A single colony can live for thousands of years, adding ring upon ring like a tree in slow motion. Scientists have found coral samples that are over 4,000 years old, still growing on the flanks of long-dormant volcanoes. These corals record the ocean's history in their skeletons. Their layers hold stories of temperature, chemistry, and change, all quietly written in calcium over time. Despite their deep homes, these coral gardens are not isolated. Ocean currents carry food particles from far away, drifting down like snow and feeding the creatures that make their lives in the dark. The volcanic rock, once part of a fiery eruption, now serves as a stable base in a shifting world. Without it, the coral would have nowhere to grow. The partnership is silent but essential. The volcano creates the surface. The coral brings it to life. To imagine these scenes is to picture a forest growing in twilight, branches waving not in wind but in water. It is to know that even in the darkest corners of the sea, life finds beauty. It does not need color or speed. It only needs time and peace. And in the slow glow of submersible lights, those volcanic cliffs become something more than stone. They become gardens, ancient and alive, holding the rhythm of the deep in every fragile, waving limb. In the coldest parts of the deep ocean, buried beneath layers of mud and pressure, there is a strange kind of ice. It looks like ordinary frozen water, but hidden within its structure are tiny pockets of gas. This is something scientists call methane, hydrate, though many know it by a more poetic name, fire ice. It holds both the chill of the sea and the heat of ancient gas, trapped together in a delicate balance that only exists under just the right conditions. Fire ice forms when methane, a simple gas often created by the breakdown of organic material, meets cold water under high pressure. The gas becomes locked inside a cage of water molecules, frozen into a crystalline shape. It looks like packed snow or cloudy quartz, resting deep within the sediment. Left undisturbed, it stays frozen, stable, and still. But when the temperature rises or the pressure drops, the structure collapses and the gas escapes. In that moment, the ice doesn't melt in the usual way. It fizzes, it burns, a solid that transforms into flame. This transformation rarely happens naturally in the deep, since the temperature and pressure remain fairly constant. But in laboratories, when fire ice samples are brought to the surface, the change is sudden and vivid. The methane ignites easily, and what looked like a dull chunk of ice becomes a source of heat. It is a reminder that even in the most silent corners of the ocean, energy waits. Fire ice is more than a curiosity. It is believed to be one of the largest stores of carbon on the planet. Vast fields of methane hydrate lie hidden beneath the seafloor, especially near continental margins and in permafrost regions. They are ancient, formed over thousands and thousands of years, built from the remains of microscopic life that once floated near the surface. As those tiny organisms died, they sank, settled, and slowly gave rise to this frozen fuel. Despite their abundance, these deposits are difficult to study. Their location deep under the ocean and their sensitivity to change make them tricky to reach without disturbing them. Some researchers believe that understanding methane hydrate could help us learn more about climate patterns and how the Earth releases carbon over time. Others look at fire, ice, and see a possible future energy source. But for now, it mostly stays where it is, quiet beneath the sea. To picture fire ice is to imagine a contradiction, something that holds both stillness and motion, cold and heat, solid and gas. It sleeps beneath layers of sediment, undisturbed, like a breath held for centuries. And yet, the moment conditions shift, it responds with a shimmer and a flame. It is not loud, it does not roar, but it reminds us that even the most unlikely places can hold surprises. The deep sea is full of them, tucked into shadows, waiting patiently to reveal their quiet wonders when the time is right. Not all changes in the deep sea arrive with heat or light. Sometimes they come with a soft shift, a movement that begins in silence and ends in transformation. One of the most overlooked of these events is the submarine landslide. It begins with a slope, often built slowly over time by volcanic activity or the accumulation of sediment. A seamount may have risen there, or a ridge may have formed from layers of lava and ash. For a long while, everything remains steady. The rocks hold, the layers settle. But then, with no warning, something shifts. The slope gives way. Stone and sediment, loosened by gravity and water pressure, begin to move. Not with the roar of a mountain collapsing, but with the soft release of an avalanche deep beneath the waves. It slides, guided by the seafloor, carrying parts of the volcano with it. What was once a solid underwater landscape becomes a slow cascade of debris, drifting and tumbling into the deeper parts of the ocean. These landslides can be vast. Some are among the largest geological events on Earth, even if they go unnoticed from the surface. One such event near the Hawaiian Islands moved enough material to fill a mountain range. Yet on the surface, there was barely a ripple. Only sensitive instruments placed on the ocean floor or satellites far above can trace the changes in shape and mass. The sea remains still, even as the land beneath it flows. The cause of these landslides is often unclear. A build-up of volcanic material, a distant earthquake, or even the shifting weight of sediment soaked with water can be enough to begin the slide. The process may take minutes or stretch out over hours, and once it begins, it is nearly unstoppable. The material that moves doesn't always settle in the same place. Sometimes it spreads out in thin blankets across the abyss. Sometimes it builds new ridges and valleys, reshaping the seafloor like a sculptor working with unseen hands. What happens after is equally important. The landslide can uncover new rock, expose mineral-rich layers, or trigger small eruptions as pressure is released. It can create new habitats, places where deep-sea creatures gather and begin again. The disturbance, though dramatic in scale, becomes part of the quiet rhythm of the deep. Life returns, corals grow, sediment drifts back down, and the slope, over centuries, begins to build again. To think of a volcano losing part of itself not in fire, but in a silent underwater fall, is a reminder that change does not always make a sound. The deep sea shifts in ways we cannot hear. Mountains grow and fall not in the blink of an eye, but in movements so slow and smooth they could be mistaken for sleep. The earth continues its work below the waves, quietly sliding, gently reshaping, always becoming something new. And in that silent motion, the story of the ocean floor moves softly forward. When lava flows across the ocean floor, it meets a world so different from the surface that it behaves in surprising ways. Instead of rivers of fire carving paths through forests or plains, the lava here is cooled by cold and pressure from all directions. The result is not jagged cliffs or chaotic rock, but something far more delicate. Lava in the deep sea often forms smooth, glassy sheets that shimmer under the lights of submersibles, as if the earth itself has laid down blankets of dark silk. These underwater flows are slower, more patient than the lava seen on land. As it pours from the vent or crack in the ocean floor, the molten rock meets near freezing water almost immediately. The outer layer chills and solidifies in seconds, while the inside continues to move. If the lava spreads thinly, the cooling process creates wide, flat sheets. These sheets can overlap like pages of a book, each one pressing softly on the one before. The surface becomes glossy and dark, with the look of obsidian and the feel of something quietly forged in stillness. These lava sheets often reflect the lights of exploration vehicles, making them appear as if they are wet even when they have long cooled. Some crack under their own weight, creating sharp edges and folded patterns. Others remain smooth for great distances, covering slopes and valleys like gentle waves frozen in place. Over time, dust and particles from above settle on them, softening their shine but never erasing the beauty beneath. What lies under these sheets is just as fascinating. Sometimes, hollow spaces form between layers where the lava drained away before cooling. These pockets become small caves, protected from the flow of water and perfect for life to take hold. Shrimp, worms, and other deep-sea animals use these spaces as shelter, moving quietly in and out of the shadows. Even though the rock is hard, the environment it creates can feel gentle. The warmth fades slowly, and life arrives to make use of the new ground. Volcanic glass formed by these flows holds clues about the conditions of the eruption. Scientists collect fragments to study their texture, composition, and even the tiny bubbles trapped inside. These bubbles once held gas from within the Earth, and by examining them, researchers can learn how deep the magma came from and how quickly it cooled. Every smooth surface, every fold, is a record of that quiet meeting between fire and sea. To picture these lava sheets is to imagine the seafloor as a canvas, not painted with bright colors, but shaped with heat and pressure into patterns that lie undisturbed for centuries. No footsteps mark them. No waves disturb their edges. They simply rest where they were formed, undisturbed and enduring. The Earth, in its slow movement, leaves behind more than mountains. Sometimes it leaves glass. And in that glass, the story of a gentle eruption is quietly written, waiting to be discovered. When people talk about the largest living structures on Earth, their minds often go to coral reefs or dense rainforests. The Great Barrier Reef usually takes the crown, and rightly so. It is vast, visible from space, and filled with brilliant color and motion. But far beneath the ocean floor, in places where light does not reach and few creatures swim, there exists something older, larger, and far more mysterious. It is not made of trees or coral. It is made of microbes, and it may be the biggest living structure on the planet. These microbial communities live in the rocks beneath the seafloor, not just on top of it, but inside it, tucked into the cracks and pores of ancient volcanic rock. The microbes are incredibly small, smaller than most single-celled organisms we know on the surface. They do not form colonies that we can see with the eye, but over time and distance their presence adds up. Entire layers of basalt beneath the ocean floor are filled with life, living in the tiniest spaces, thriving without sunlight, and surviving on nothing but chemical reactions between rock and water. What makes these microbes so special is not just their location, but their patience. They live slowly, dividing perhaps once every few hundred or thousand years. Some scientists even wonder if they are living at the very edge of what life can be. Their energy sources are minimal. They feed on the faintest whiffs of hydrogen or iron or other elements that seep from the rock. They do not move much. They do not grow quickly, but they endure. The volcanic rock itself is part of the reason they survive. When lava cools on the seafloor, it leaves behind porous basalt, riddled with cracks and spaces just wide enough for water to flow through. That water, warmed slightly by the Earth's heat and rich with minerals, brings what little nourishment these microbes need. They settle in and wait, forming invisible mats and networks across the stone. And over millions of years, they become a part of the rock itself. These microbial structures are believed to stretch for hundreds of thousands of square kilometers beneath the ocean floor. Their exact size is unknown, but they may rival or exceed the size of any living structure on the surface. And yet, they are hidden, silent, unseen. They do not bloom or shine, they simply exist. Studying them is not easy. Samples must be brought up from deep beneath the seafloor, often through drilling projects that take years to plan. But even in small pieces of rock, the evidence is there. DNA. Tiny cells. A signature of life that stretches far beyond our ordinary view. To know that such a vast community lives quietly beneath our feet, deep inside stone, is to feel both small and connected. The planet holds more life than we can see, more patience than we can imagine, and sometimes the largest things are those that never ask to be noticed at all. In the deep sea, change often comes without sound. A volcano may erupt, a mountain may shift, or a new vent may open, all without the noise we associate with movement on the surface. One of the most curious examples of this is the way some deep-sea earthquakes begin, not with a sudden jolt, but with a silence, a pause, a moment of stillness before the earth decides to move. Beneath the ocean floor, tectonic plates are always pushing, pulling, and sliding against one another. These movements are slow and steady most of the time, but pressure builds. Rock resists change, but only for so long. Eventually, something must give. What is remarkable is that many earthquakes do not start with an explosion or a violent snap. They begin with a gentle slip, a quiet rearranging of stone. No sound, no tremor felt above, just a slow shift deep beneath the seabed, like a door easing open without a creak. Scientists call these events slow slip earthquakes. They can last for days or even weeks. Instead of breaking suddenly, the plates ease past one another gradually. The movement is real, measurable with precise instruments, but it feels like the earth is stretching rather than cracking. These quiet quakes release energy without drama. They happen far below the waves, often in regions near underwater volcanoes or subduction zones, where one plate is sliding beneath another. Though these events are calm, they are important. They can change the way pressure is distributed along faults, setting the stage for larger, more traditional earthquakes. In a way, they are the Earth's method of adjustment, a kind of exhale that keeps the planet in balance. And yet, we would never know they were happening without tools designed to listen to the deep. Around these slow slips, the water remains calm. The fish continue to swim. The sediment settles gently, unaware of the motion beneath. But the rocks remember. Tiny cracks form. Heat may rise slightly. In some cases, fluids trapped in the crust are released, feeding deep-sea vents or triggering small changes in chemistry. These quiet moments can mark the beginning of something new, even if they pass unnoticed by the world above. There is something comforting in the idea that the earth does not always shout. Sometimes it whispers. Sometimes it moves in such a gentle way that no one would think to look. And yet, these silent shifts are just as powerful as any loud eruption. They reshape the land, reset the balance, and remind us that the deep sea is not a place of stillness, but of motion wrapped in calm. To imagine this is to picture a sleeping giant turning over, not in anger, but in peace. A slow breath, a small adjustment, a movement that changes everything, yet tells no one it is happening. The deep sea keeps its secrets well, but those secrets are always unfolding, always becoming part of the next quiet chapter in the story of the Earth. Not all eruptions wear the fiery colors we expect. In the deep sea, there are volcanoes that do not spit rivers of lava or coat the ocean floor with glowing stone. Instead, they release something more subtle, a mix of gas and superheated water that escapes from the seafloor in a gentle bloom. These underwater eruptions often come not as explosions, but as a kind of underwater shudder, a soft release of pressure, a sigh that drifts upward through the water in streams of bubbles and heat. The gas in these eruptions is usually carbon dioxide, though other gases like methane and sulfur can be present too. Some of it forms in the magma deep below, trapped until the volcano finds a way to let it out. When that moment comes, the release can happen quickly or slowly depending on how the rock shifts and how the gas escapes. The bubbles rise, often in great curtains, like soda being poured into a quiet glass. It looks peaceful, even beautiful, as tiny spheres of gas spiral toward the surface. This kind of eruption doesn't always change the shape of the seafloor in dramatic ways. There may be no new lava flows, no towering chimneys of rock. Instead, the volcano leaves behind a trace of warmth and a slight change in the water's chemistry. The gases mix with the surrounding ocean, feeding certain types of microbes that flourish in the presence of carbon and sulfur. These microscopic organisms become the start of a new food web, one that lives not off light, but off the breath of the planet. Some eruptions release enough gas to change the water's buoyancy, or even its color for a short time. In rare cases, the gas can collect under the seafloor, and then escape all at once, causing a burst of bubbles strong enough to disturb the sea above. But most of the time, these releases are soft, calm, and easy to miss unless you know where to look. Instruments placed on the ocean floor can detect changes in temperature, chemistry, and pressure, helping researchers find and study these quiet events. One place where this kind of eruption has been seen is around volcanic islands, where the seafloor is young and full of fractures. The gas slips through these cracks, not with force, but with persistence. It travels up through the water column, sometimes in steady streams, sometimes in bursts, carrying the deep breath of the earth with it. To imagine such an eruption is to let go of the image of flame and thunder. Instead, picture a gentle fizz, like warm mineral springs rising in the shadows. The ocean does not roar, it bubbles, and in those bubbles are the stories of volcanoes that choose not to shout. They reshape the sea in silence, adding warmth, feeding life, and reminding us that not all power is loud. Sometimes it drifts, soft and rising, through the quiet waters of the deep. The ocean is often described as timeless, a place where things stay the same for eons, but even within its vast stillness, the sea is constantly in motion. Water shifts, animals migrate, temperatures rise and fall. What surprises many is that the deep sea, particularly the parts shaped by volcanoes and trenches, holds some of the oldest places on Earth. Older than mountains, older than the land we walk on. In fact, parts of the ocean floor have remained untouched for hundreds of millions of years. These ancient regions lie especially in deep trenches and around slow-moving seamounts, where geological activity is less intense and erosion happens at a much slower pace. Here, the crust is thick and settled. Lava hasn't flowed in ages, earthquakes are rare, and sediment drifts down so gently that it takes thousands of years to form even a thin layer. The quiet is so complete that time itself seems to gather and rest. What makes these regions so enduring is how they are shaped. When volcanic activity creates a seafloor, the new crust is warm and buoyant. Over time it cools, becomes heavier, and sinks deeper into the Earth's mantle. Eventually, that crust may be pulled down into subduction zones and melted, only to rise again elsewhere as fresh lava. But some portions escape this cycle. They drift slowly, carried by tectonic plates, moving inch by inch across the globe. In deep basins or under the protection of stable ridges, they remain intact, rarely disturbed. Within these zones, the rocks tell stories that the continents have long forgotten. They hold records of ancient ocean chemistry, past climates, and even tiny fossils of creatures that once swam near the surface when the world was still young. Scientists collect samples from these old seafloor regions to piece together Earth's long history. In these layers, buried in the dark, are clues to everything from mass extinctions to how the atmosphere once behaved. Despite their age, these places are not frozen. Life continues, though very slowly. Microbes live within the rock itself, drawing energy from minerals. Small creatures sift through the sediment, feeding on the marine snow that falls from above. The processes are subtle. There are no rushing currents or bursts of color, just a gentle persistence, a kind of patience that feels more like breathing than moving. To know that parts of the deep sea are older than the tallest mountain or the deepest canyon on land is to understand that time behaves differently here. It does not rush, it settles. It accumulates in layers, in silence, in cool darkness. These places do not ask for attention. They do not reveal their stories easily. But they are there, beneath the weight of water and centuries, holding on to moments the rest of the world has long forgotten. In the quiet of the ocean's oldest places, the earth keeps its memories, not as noise or motion, but as stillness, as deep, enduring presence, a reminder that even in constant change, something ancient remains. And so, as you drift off and let your thoughts wander through layers of water and stone, remember this: the earth is always breathing, even in the deepest quiet. Volcanoes rise and cool like slow heartbeats. The deep sea glows without sunlight, and somewhere beneath your feet or far below the waves there's always something ancient unfolding in silence. If this journey brought you a little peace tonight, I'd be so grateful if you gently liked the video, left a sleepy thought in the comments, or subscribed for more soft wanderings through science. Sleep well, and may your dreams be full of shimmering reefs, sleepy vents, and warm lava flowing like honey beneath the sea.